So folks, in this video, I will try to kind of illustrate the concepts and demonstrate the implementation of IP multicast. So just to get a quick review of how networking works. Networking primarily is thought of as unicast to unicast communication. Unicast to unicast means you have one source, like your PC that you're sitting on, and it's got a source address, source IP address, say 10.1.1.1, that's a source address. And you're trying to reach a destination, which is most likely a server that has a destination 100.1.1.1, and that's your destination. So this source to this destination communication is unicast to unicast networking. Then you got this unique, and when you are like sending it to a broadcast, then you have a unicast to broadcast. And this happens when you are ARPing most of the time. Address resolution protocol saying I've got an IP and what is the MAC address, or I've got a MAC, what's the IP if you were to do the reverse. So unicast to broadcast, broadcast is pretty much from yourself to everyone else that's sitting on that particular subnet. And ARP is one example of that. The third, so this was like your first, and this is happening pretty much all the time on a subnet, on a switch, or a router for that matter, or for, on a PC for that. Every device that's got an IPv4 will ARP. IPv6 does not ARP. It's got a different mechanism, which is dependent on multicast. So we'll talk about that later. But ARP is pretty much IPv4. If you've got IPv4, you're ARPing. Your PC, your switch, your firewall, your router, any L3 device that's got an IP will ARP. And that's unicast to broadcast, basically, on that particular subnet. Okay. All right, so that's one. Broadcast is two. And then the third one is multicast. And that's where IPv6 how works, multicast. But in general sense, on a high level perspective, you have a source and your destination, or the multicast group that you're listening to. So you have a source, which is a single IP. And the way multicast works is in a reverse direction. So that's kind of a little difficult to grasp initially, but the multicast protocol or technology works in the reverse direction, as if you're driving in reverse. So you have 224 or 230, let's just say 230, a multicast group address, MCAST group address that you want to listen to. But when you want to listen to it, you would subscribe to it. And when you subscribe to it, the source, the server that is generating that stream, would send it to you. So it's in this direction. You just want to say, I want to listen to 230.1.1.1. It's just like a channel, right? You just flip the channels, and each channel is a different group. But each time you switch the channel, you are basically telling the network, I want to listen to this group. So when you say I want to listen to or have a stream of 230.1.1.1, the source is already sending, you are just subscribing to it. So the flow would come to you when you subscribe to it, when you say, I want to join. So in multicast, you have protocol independent multicast protocol, which is basically doing the routing, multicast routing. And then you have IGMP, Internet Group Management Protocol, which basically signals the joining of the groups. So routing and signaling of multicast on a very, very high level perspective, right? So we're not going in the details. So multicast, I will illustrate how to verify it on a Cisco CSR. So I think the way it's going to look like is probably do 2-3 routers just to show how PIM works. Put this guy on a multicast, so they're going to be doing PIM here and PIM here, protocol independent multicasting. So they're basically routing the multicast traffic. On this guy, for example, I will put on a loop back and I'll say IGMP join. I'll make this guy the RP, rendezvous point, for IGMP and the source. So this guy is going to be the source. And the way we're going to make it source is we're going to generate pings to a multicast group. So ping is a source, you're generating traffic. So now the source, multicast source, is basically pinging on this group and basically watching who responds or who is listening. Whoever responds is listening. So here I'm going to do an IGMP join 230, 111. If I don't do this, it's not going to respond. If I do this, if I do the join, the source will get a response back. And this is only Cisco that lets you verify this ping. I haven't tested Juniper or VIOS yet. VIOS just introduced multicast. I'm not sure if it's totally big, but I did try the ping on VIOS and it didn't work. So Cisco does provide you the ability to ping a multicast group and see who's responding or who's listening. So in a very simple topology, we're going to run PIM. You're going to configure a static RP, and then there are multiple ways. You know, the old ways was sparse dense. It was dense first initially, then came the sparse dense, and then the sparse. Basically, what these are is like, this is like flood everywhere where PIM is enabled. And this was like flood and prune, and this was is only go where the IGMP is. 3 different philosophy, and there's a 4th one which we're not going to talk about right now. But we're going to implement sparse dense, sparse mode only. PIM sparse mode with an RP. RP is basically a rendezvous point where the multicast client would meet the flow. So the source would just generate the stream towards the RP. And since it's in a reverse way, it's not a unicast routing, the client would go to an RP to receive that until they meet the shortest path forward. Now, it's very complicated, so I'm going to make it extremely simple and not get into the shortest path tree of multicast. Multicast is fairly difficult, but just to make it work and give you the concept of what's happening, the client is listening to the group, and how do we verify that? So we're going to use PIM sparse mode, RP, and see if this one is going to work. Okay, 2 protocols: IGMP, PIM, sparse mode. So let's see if I can bring up my routers. So we're implementing this topology here. R123. Excuse my drawing. So now I've got 3 routers running. This is my R1. To see what's going on here though. Show IP interface brief. I've got 3 interfaces going. Show IP route. I've got ISIS going. So I think I'm able to actually want show IP interface brief. Ping 12001, I can. Ping 23003, I would say, I can. Show IP mroute. I don't have anything, so multicast is not enabled. Show IP mroute. So your unicast needs to be working. Show IP. Show IP mroute. Nothing. So I've got this going here. And if I were to redraw this, it would probably help. So what I am doing here basically is this. My router 1 is connected to router 2. These are Cisco CSRs, R3. This segment is 12.00x. This segment is 23.0.0x.3.2.2.1 loopback, probably 1.1.1.1/32 loopback 333/32 loopback 222/32. This guy is going to do IGMP join on the loopback. It's also going to do IP PIM sparse mode. And then this is going to be IP, let me do this, IP PIM sparse mode on this guy, this guy, this guy, this guy, and the loopback. The IGMP join will only come here, and I'm going to say join 230, whatever, 230, any multicast group. And then I'm going to generate ping 230 from R3, 1.1.1, and it should respond. That's a sign that your multicast is working. Let's see if we can make it that happen. Your unicast needs to work, basically meaning your reachability of all the loopbacks should be there through whatever IGP you choose to. So let's see, show IP route. Can I reach, also it just stopped, so can I reach loopback 111? Yes, I can. Can I reach 222? Yes, I can. Can R1 reach R3? Can I reach 222? Yes, I can. So we're good from a unicast perspective. I've just implemented ISIS with stub routing from previous video, I guess. But let's implement IP multicast. Nothing is running right now. I show IP mroute. All right. So now you got to go IP multicast routing. Okay. Distribute distributed. Every version of iOS is a little different. Enable routing multicast distributed. IP multicast routing distributed. So routing is enabled for multicast. Now I need to configure on R3 the pins. Do show IP interface brief. Which one is 23? It's gig 1, interface gig 1. Do show run interface gig 1. Anything fancy? Nothing there. Just regular. So I'm going to go and say interface gig 1, IP PIM, sparse mode. Okay, and then I'm going to say IP PIM RP address is going to be my 2222. That's pretty, and my loopback, of course. Do I need loopback? I don't really need loopback. Okay. Now let's go to R2. do show run interface gig 1 is 12. Nothing there. Do show run gig 2. Nothing there. Do show run interface loopback 0. Nothing there. Okay, so interface loopback 0 is my RP, so I do IP PIM, sparse mode, IP, okay, and interface gig 1, IP PIM, sparse mode, interface gig 2, IP PIM, sparse mode. And then let me tell you who your RP is, which is yourself, IP PIM, RP address is yourself. All right. Let's see, do show IP PIM neighbors. I got one up. Let's go configure R1. So interface do show run interface loopback 0. Nothing there. Interface loopback 0, IP PIM, sparse mode. Interface do show run interface gig 1. Interface gig 1, IP PIM, sparse mode. And then I'm going to say IP PIM RP address is 2222. On interface loopback 0, I'm going to say, so before I do the join, let me go and ping this guy first. So go here on R3, and this is my source, right? So I'm generating a source, multicast source to whoever is listening. So I'm going to say 230, and I should not get any response. Run it one more time. No response. Show IP mroute, and I get an mroute for 224, which is an RP listening device, which is RP222, which is good. Nothing else. 23003 was trying to reach here. So incoming interface was gig 1, this guy, and outgoing is null. But I did not get any response. So you will see this when the stream gets generated. So show IP mroute will tell you who's trying to reach what group, who's the source, who's the multicast group that he's trying to reach. Okay. So even though it's trying to reach, there is no response. But let's go configure IGMP on this baby. Interface loopback 0, IP IGMP join group, and then generate the ping. Show IP mroute. You got the basic RP thing, and no source for this guy yet. Show IP mroute. Okay. 230. He saw that because he's the RP. 2 is the RP, so he saw that coming for 230.111. You'll see all of this is going to change. The outgoing and the interface. Incoming is gig 2, gig 1. So let's generate this now. Since I've put an IGMP here, first one's an ARP. Not joining yet. Okay, what's going on? Show IP PIM neighbors. I've got one neighbor here. Show IP PIM neighbors. Oh, I should have 2. Okay. Show run interface gig 1. I've got PIM sparse mode on gig 1. Do show run interface gig 2. I got PIM year 2. So what's going on? I should have 2 on R2. Show run interface. Show run interface loopback 0. PIM sparse mode. Show run interface gig 1. Gig 2's got. Gig 1's got. So show IP PIM neighbors. We need 2 of these. Why am I not seeing gig 1? Show run interface gig 1. Got this. Let's go check R1. Show run interface gig 1. I've got sparse mode configured here as well, but that's not the right interface. I've got to put it on 2, and 2 doesn't have it, so that's my problem right here. Interface gig 2 IP PIM sparse mode. Now I should see 2 neighbors right in the middle of this router. So he should have 2 PIM neighbors, right? Show IP PIM neighbors, and I got 2. So now I should be able to ping this guy. Aha, see this? So I got a response from 1111, which is this guy right here. So now let's take a look at the mRoutes. Show IP mRoute. I've got a source and got a destination. I've got a source. See, it's reverse. I've got a source and I've got a listener. So multicast is reverse. Incoming interface is gig 2 and outgoing is loopback 0, which is my loopback. This is R1, okay? Yeah, R1. R2 should show you show IP mRoute. Should show you incoming 2, outgoing gig 1. There you go. So incoming is gig 2, outgoing is gig 1, and I've got a source. 230 is my source, and the listener is 2303. So back this up. Again, multicast is confusing. My source, which is generating 2303 for this stream, is this guy. You got to know how to read this stuff. It can be confusing again. This one, 224.1.40 is the RP, listing address. Your routing protocols like ISIS, OSPF, and IPv6 works on multicast. So if you sniff it, you'll see a lot of multicast addresses. But generating traffic on a multicast to make it run is obviously it's confusing, but now we can see it's working. Your source is right here, and it's generating ping towards the group. So this group, the client is joining and listening to this group. So reading the mRoutes obviously can be tricky, but again, multicast does require your unicast to be up and running before you can actually configure it. So it's very simple to test and configure, but the concept itself is a little tricky because it's obviously going in a reverse direction. So Cisco CSR lets you do this ping business. That lets you test it, and it will respond back nicely saying, hey, this is the client. So if I want to generate another client to see, this one is saying this is the client who's listening. So let's say I want to put up another client on the same config T interface loopback 1 IP pin, sparse mode, IP address 11.111/32. And I'm going to listen to another group called IP IGMP 230.222. IP IGMP join 230.2222, not one. So let's see, it'll give you this address now, that this is the one that's responding. And your multicast routing table is going to look very complicated. Okay. 230.222, right? Let's see. There you go. Who's the listener? Should be 11.1. There you go. And now let's take a look at the MCAST routing table. It's going to be big. This was before the second client. This is just for one client, right? Now let's take a look at it. We got multiple clients listening. So you got 2303 listening on this. You got 2303, which is, again, the pings are generated from here, the source. And you can put a source wherever you want. You can put more routers. And the second one is the second group is 230.222. 230.111 is the two groups that is getting used for streaming. There are two clients that are listening to it. And the client address is not listed here except for the source. And the client would obviously be determined when you get the ping response. But you can see how the multicast table looks complicated. Let's ping 1. And 2. Two clients listening. So you can verify who's listening from an IGMP perspective. Cisco lets you do that verification validation pretty easily. So hope this helps. It's just like, again, it's the concept that is way difficult to understand than the implementation itself. So, but the purpose of this video was to see if your multicast is working or not, at least in Cisco scenario, and hope this will help.